It's 3 o'clock. We'll wait for 5 more minutes.
Yeah, sure, sir, no problem.
Others join.
Hi, sir. Am I audible now?
Yes, you are audible.
Okay, sir. Thank you. Sir, if I may ask, what will be the the methods you will be teaching us today, like as in like the doubts and everything.
Okay, so what we'll cover today, I'll
Uh-huh.
start with the solutions of the week zero assignment.
Right, sir.
Since the assignment 1 and 2 dates have not been means it's the submission date is not passed, I'll
Yes, sir.
cover the questions which are related to that assignments.
Fine, sir. No problem.
Hmm. So, hello everyone. I welcome you all for this discussion session of NPTEL January to April 2025 batch of finite element method. My name is Nikhil Gupta. I am a research scholar in Indian Institute of Science, Bangalore. So, last time we completed few questions and the theory part. This is the week 2 of this class. And so before start, are you guys able to have an access to these videos and the PDF which are being uploaded?
No, sir.
No, I
So,
don't have.
so you don't know how to access these videos?
No, sir, exactly. Because last week there was a session, but unfortunately I couldn't attend.
Okay,
And
so
I also posted the query for the same. Where can I find those YouTube recorded sessions and everything?
so did you post that query in the that forum, Google forum?
Yes, sir. I believe I did that. Let me just.
Okay, I didn't saw that. Otherwise, I would have messaged you. No problem. I'll show you the where to get it. So this is the video we have uploaded. You can directly search. You search FEM NPTEL TA session in the YouTube, and you will get my YouTube channel as Nikhil Gupta. We are supposed to upload the YouTube videos. If you have any problem, you can directly message to the Google forum. But this is the lecture video link. You just type FEM NPTEL TA session. I have mentioned the it as like this, so you will get it.
And what about those PDFs, sir, which you have used in that?
PDF also. I'll do one thing. I'll do one thing. I'll post that link in the Google forum. Otherwise, I have submitted the link to the NPTEL team. I think they should have given you till now. I don't know where is the miscommunication. But surely, what I'll do, I'll update the link in the Google forum, and there you can have the access.
Okay,
Okay.
sir.
So let's start today's session. So what I'll be covering today, as I was telling, today I'll start with the week 0 solutions. I know that is not really related to FEM. It is the things. So let's begin and do a recap of the prerequisite which we require. Since you do not have to upload this week 0 assignment, but you should have the gist of how to solve them. Later, since the I know you are going to submit the assignment 1 as assignment 2 this 5th, so it will be helpful for you to get the questions which are related to it, which will be solved today. So this is the question number 1 of the week 0 assignment. Did anyone solve? This is a very easy, simple question. So I won't wait for this question because this is very simple. So what you have to do in this, a set of linear algebraic equation is given in the form of matrix form, and you have to get the values of x and y. So it's generally, if you see, this is the ax into b is equal to b form, where A matrix is 1, 2, 3, 5, X matrix is xy, and this is 7, 6. So to get X and Y, we'll take A inverse, which will be 1, 2, 3, 5 inverse into 7, 6. So that's pretty simple to solve. I won't go in much detail for this. And the solution what you will get, you can check your solution, that will be this. So x is 23 and y is 15 in this case. So let's focus on the second question, which says A matrix is n into n matrix, x is n into 1 non-zero vector, where Ax is equal to q square x, or rather I should write it capital, so quite confusion between vectors. So you have to find the eigenvalues of it. So what eigenvalue problem says? It says Ax is equal to lambda x. So if you compare these two equations, what you will get? You will see lambda is equal to x square. So this can be concluded as this, that A has the eigenvalues which is q square. So simply, if you want to know the eigenvalues of A square, we simply note that lambda square happens. So here q is equal to 4, and this is your answer. So now let's go to the third questions. Third question. So what it says, the differential equation governing the free vibration of a spring matrix, spring mass system consists of mass m attached to a spring of stiffness k is given. This is the general 2-degree equation which we know, where y is the equation of motion, and y the solution of y is also given with a as non-zero. This is a little tricky question. If anyone want to comment, you can let me know. I'll give you a 1 or 2 minutes time. Okay, if no one wants to give the answer, I'll continue. So this is the differential equation which is given. The solution is also given as this. Since you know this is the solution of this equation, so it must satisfy this condition. This equation it should satisfy. So what we can do, we can put this equation in this the solution in this differential equation, and we can get the solution of it. So what we'll get, you will directly put it and you will get a minus 2 pi v square m plus k cos 2 pi vt. I'm skipping the sum of these steps because they are pretty simple. Okay, so if you want to solve these equations, three things can happen. One, a can be 0. Another thing can happen, that this can be 0 or this can be 0. So it is given the question that a cannot be 0, so this is not the solution. And if you want to satisfy the y as the solution, for all t it should happen that this equation should satisfy. But if you see this solution, it will give you as 2 pi vt as 2n plus 1 pi by 2. Otherwise, if you solve from these equations, what you will get? You will get k as m 2 pi v whole square. So if you solve this equation, you will get the solution as v is equal to 2 pi under root k by m. So if you see the solution, this is the C part. So this is the another simple question where you have to know that you have to tell that in a two-dimensional plane stress problem, the various non-zero stresses are. So this is very simple. We know stress component sigma can be represented as sigma xx. Let's generalize this, not initially start with the 2D. So what generalized equation say is sigma is equal to sigma xx, sigma xy, sigma xz, then sigma yx, sigma yy, and sigma yz, then sigma zx, sigma zy, and sigma zz. So now let's focus on the problem which is given. It says plane stress problem and in xy plane. So since it is xy plane, we know all z components will go 0. So this will go 0. So what are the terms which are left? Are sigma xx, sigma xy, sigma yx, and sigma zz. Now you know from Maxwell reciprocal theorem that these two will be equal. So what we can say that sigma terms which are available with us are sigma xx, sigma xy, and this is not sigma zz, this is sigma yy. So will be sigma yy. So if you say which answer it is, so it is C, sigma xx, sigma yy, and sigma xy. Okay. So now let's focus on the question number 5. So what it says A is a matrix. A is a 3 cross 3 matrix, and B is also a 3 cross 3 matrix obtained by multiplying each element of A by a scalar. That is B is equal to RA. Which of the following is true? So B is given as RA. So now if we see the options which are given, so that directly it wants to compute us the determinant of a matrix B. So how to get it? Anyone wants to give a try?
Determinant of B is equal to determinant of A. Option B.
Okay, you are saying option B. But what
Yes,
what
sir.
about R which is there? Where will it go?
Sir, because it's a scalar, if matrix is multiplied by a constant, the determinant remains the same.
No. Okay. Anyone else who want to try? Okay, but the answer is
It should
wrong.
be option D, no?
It should be option D. Yes. So why
Yes.
it will be option D? Let's take a matrix like one like this, and if you multiply a lambda, some constant, it will be like this. And there is a property which says that when we take a determinant of a matrix, the scalar is multiplied with that it gets means scalar gets the power of the matrix dimension if we do a like this. So here the option will be determinant of B will be R cube of determinant of A. So question number 6. This is a theoretical question where it says that consider a body in a state of pure stress. What will be the following option holds for this to be true? So let's see how it is done. So let's see, this is a body where pure shear is acting. Okay, so we know from strength of material that if pure shear is there, B, yes, B is the correct answer, Mahesh. So if this is a pure shear stress member, if we make a angle at 45 degree, we'll see one member will be like this, member force, one will be like this. One will be compression in one direction, one will be tensile in other direction. When we use the formula of the principal stresses, this will be the direction of the forces which will get at 45 degree. and the solution will be B. So this is again a simple question where which we have to find the eigenvalues of eigenvalues of matrix A. This is just a simple question, a mathematical question. So A is 4 7 0 2. So we know that for to find the eigenvalues, what we will do, we find the solution of this equation where A minus lambda I determinant is equal to 0. So where lambdas are the eigenvalues of this matrix. So we'll write that determinant of 4 minus lambda 7 0 2 minus lambda equals to 0. When you solve this, you will get lambda square minus 6 lambda plus 8 equals to 0. After solving, you will get lambda 1 as 2 and lambda 2 4. So which is your answer? It's the A. Okay. So the 8th question. If a Young's modulus and Poisson's ratio of a material are 70 and 0.29 respectively, what is the value of rigidity modulus? So this is the sample directly the formula based question. Do anyone remember the relation between the E and the G? Young's modulus and the rigidity modulus. It's pretty simple. You must have studied in the strength of material course in your undergrad course.
G is proportional to y cube.
No, G is proportional to
Y cube.
what
Young's
is y?
modulus to the
Nu?
power of
No. This
yeah,
is
Young.
y nu cube.
Yes,
Yeah.
sir, mu cube. Young's modulus power 3.
No, this is not the formula. Do you remember this formula? E is equal to 2g 1 plus nu. So this is the formula you have to
No,
use.
sir.
So can anyone tell which type of material is this? Is this isotropic? This is anisotropic, orthotropic? Just getting away from this question. Why these only two constants are there? Which type of material is this? Isotropic, orthotropic, anisotropic? So this is an isotropic material. Why is it isotropic? For isotropic, we require only two constants, or what we say as material constant, to define our material behavior. So what we'll do, we'll substitute the values where G is equal to 2 upon 1 plus nu, and you'll substitute 70 upon 2 1 plus 0.29. The solution will give you 27.13 GPa. So it's just the simple option number C, the simple question, just the question that formula based. So let's go to question number 9. What it says: consider a square plate of overall dimensions this. Okay, Young's modulus and Poisson's ratio of plates are specified. What is the change in the volume of plate if it is subjected to longitudinal tensile stress of 65 MPa? Okay, so what is given here? Here it is given as E as 65 GPa. Okay, other thing which is given as nu as 0.28. Poisson's ratio is given. Now sigma x is given as 65 MPa. So since other sigmas are not there, so what will say sigma y, this is y, and sigma z will be equal to 0. So another thing which we can compute is volume of plate, which is 200 into 200 into 10, which will be 4 into 10 power 5. Okay, 4 into 10 power 5. Now what we have to find, we have to find the change in volume. So change in volume can be computed through volumetric strain, which is dV by V. So we know a formula for from strength of material, the sigma x plus sigma y plus sigma z upon E 1 minus 2 mu. The direct formula we have studied earlier in the strength of material course. When you put the values in it, which will be 65, other will be 0, and E is given as 65 GPa, so it will convert it as it into 65 into 10 to the power 3, then 1 minus 2 into 0.28, and we will solve it. You will get the value as 4.4 into 10 to the power minus 4. So since we know that this, we have to calculate the change in dV. We know the value of V, so we can directly calculate the change in volume, which will be dV by V equals to 4.4 into 10 to the power minus 4, and dV will be 4.4 into 10 to the power minus 4 into the volume which we have calculated as 4 into 10 to the power 5, and it will come out to be 176 mm cube. So answer is A. So I think this is the last question of the assignment, question number 10. Now you have to find the rank of the matrix. So this is the simpler linear algebra prerequisite of the course. So the matrix is given as this: minus 10, 7, 12, 5, 3, 1, 10, minus 20, minus 26. Now let's reduce this matrix into the echelon form so that we can directly get the rank of the matrix. So what we'll do, we'll replace R2 as 2R2 plus R1 and R3 as R1 plus R3. So the resultant which we'll get will be minus 10, 7, 12, 0, 13, 14, 0, minus 13, minus 14. So still we see that there is echelon form is not there. So what we'll do, what we can do is we can add these two, so that this minus 13 and the 1 will go 0, and we can move further towards the echelon form. So we'll write the equation, the transformation as R3 changing to R3 plus R2, and you will do this, you will get the equation, the matrix as 10, 7, 12, 0, 13, 14, 0, 0, 0. Now what we can observe, that this is the perfectly echelon form of the matrix, where two rows are non-zero, one this, one this. So directly we can say rank is equal to 2. So option number C is right. So till here I have solved the assignment number 0, which have been given to you. Till you don't have to submit that assignment, since it was the not related to FEM. I solved it very fastly, so that since you have you have solved it, so you should have the solutions of it. Now let's start with the questions which are related to your assignment 1. These are not the questions which are given in your assignment. Once your due date is over, I'll like the with the way I solved the assignment number 0, I'll surely solve the assignment 1 problems also. But I think I have 10 or 11 questions here which are directly related to assignment 1 problems. So let's start with the question number 1. Have a look on it and let's think about it. I'll give you 2-3 minutes to read the question.
I think it should be 8 by 8.
8 by 8. Anyone else? Okay, no problem. So what we can see in this, choose the correct option for dimension of global stiffness matrix for entire truss. So last time I told you the difference between elemental stiffness matrix and global stiffness matrix. So here they are talking about global stiffness matrix. So we have to calculate the degree of freedom for each of the means for all the elements combined in this truss and get the dimension of global stiffness matrix. So let's say I'll denote this as A, this as B, this as C, and this as D. So since this is a 2D structure, we know this is X and this is Y. So each of the A, B, C, D will have 2 degree of freedom. One in X direction, one in Y direction. So 2 is for this, 2 for this, 2 for this, 2 for this. So what you get? 2, 2, 4, 2, 6, 2, 8. So directly you can say the solution will be 8 by 8. Now let me go to the question number 2 and try to get the answer.
With 2D element.
2D element, sure. So why this is 2D element? So I'll differentiate. If this is your element, these are your node. So you say this is 1D element because you are considering the degree of freedom in X directions only. If you say that this is a plate or a square, this you will consider X and Y. So this is a 2D element. Similarly, if you take a tetrahedral element like this, you will see this is a 3D element because for each of these X, Y and Z all are important. So you can differentiate. This is a 4-noded quadrilateral. So 1, 2, 3, 4-noded quadrilateral. This is a 2D element. Now choose this. It's a theoretical question.
It's option C.
Okay, you say both 1, 2, 3 are true.
Yes.
Anyone else want to try?
Yes,
Okay.
sir. Option 1, 2, and 3 are correct.
1, 2 or 3. You say all 3 are correct. So no, this is
I think I'm in doubt. I think it's option D because
D. Uh,
Sir,
yeah,
but
D, sir, D.
yes, it should be D.
yes, it's D.
One is false.
So let's start with 2 and 3, which all says that it's true. That nodal displacement is basic unknown for direct approach. Yes, whenever you solve a question, nodal displacement are the basic unknown. You solve it. So it is correct. Now, when we solve the FEM problem, it provides a approximate solution. Yes, whenever we have seen that FEM solution is only based on the approximation of the solution, and we get the solution at the nodes correctly. But Why this is also wrong? Because whenever you do use a direct approach, each of the physical system has some each physical system we take some approximation and then solve it. So either you are solving a finite element method or a direct approach, you will still get a approximate solution only. So one is false, 2 and 3 are the correct answer, true. Now read this question. This, so just tell you that brick element is a 3D element. This question don't have anything with this 3D thing, but
Eight,
It's
sir.
like
Eight.
8 node.
Eight node.
8 node.
okay. So anyone knows how a brick element look like? You have seen a real brick.
Yes, sir.
So brick element will be like this. Understood? Now the people who are saying that it will be 8, I think what they are saying that 1, 2, 3, 4, 5, 6, 7, and this is 8. Am I right?
Yes, sir.
So read question one more time. What is the difference and why this is not the answer? Okay, before giving the answer, I'll give you a hint.
Is it D, sir? Because each phase we have to connect, we have to mesh it
Okay.
like as a part of like discretization
Okay.
process.
So how many you are saying?
Uh, for example, like eight nodal points are there,
Okay, yes.
and then multiplied by four sides, if I'm not wrong.
Go ahead, you're right.
So 8 into 4, 32. Because there will be like when we are separating those phases,
Okay.
so there will be information exchange between those same nodes, right? For example, uh, I don't know how to represent that
Okay,
here,
no problem. I'll tell you. So
but is it right or wrong?
no, 30, you are going to the right direction, but 32 is not correct. I'll tell you what
It
the
should be
solution.
20.
It should be 20. Yes, correct. So
Okay.
I'll tell you how it is. Let's see. This is two node and linear element. When you will get a solution. What you will get? Let's say this is u1, this is u2, some value of u1 you are getting someone. Now you have approximated as linear, so you will get a linear like this. Now let's say this is two noded quadratic element. Now you get u1 this, u2 this. Now can you define a path between u1 and u2 which is unique quadratic? Did you guys get my question? In linear you can say yes, this is the unique path that we see. We can connect u1 and u2. Is there a unique path between u1 and u2 for quadratic element?
No. 3 points are
3
required.
points are required. Now if you say, I can say you can go like this also, you can go like this also, or you can go like this also. So for a unique path you require one more point. Let's say like this. So what you can do, you can directly do like this. Okay, so the what is the output we have to consider here, that for quadratic element we require 3 points. Like let's say we have a cubic element, then we require 4 nodes, 4 points in a node, in 2 nodes, 4 points in 2 nodes. Now let's come back to this question. Now since this is a quadratic brick element, here it will be parabolic, here it will be parabolic, here it will be parabolic, here it will be parabolic. So consider all this. What we have to consider, let's say This is brick element. So 1, 2, 3, 4, 5, 6, 7, and 8. Now, for each of the element, you should have a node here. Should not have
Additional.
node here, 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 node here. Now let's count it. This is 1, 2, 3, 4, 5, 6, 7, 8. 8 are the outside ones. Let me be more specific with the color so that it's not confusing. This is 1, 2, 3, 4, 5, 6, 7, 8. Now
12 extra.
12 extra. 9, 10, 11, 12. Down one 13, 14, 15, 16, and vertical members 17, 18, 19, 20. So brick element quadratic will have a 20 elements. Okay. So this is the same question, a theoretical question, and the same one which we have solved. I think you can give the answer for this.
It's A.
It's A.
Approximate solution.
Okay. So what do you understand with by this closed form solution?
Is it something related to the
Boundary
boundary condition?
condition.
It is related that whenever you say a problem is having a closed form solution, you say that
Within a
solution-
limit.
within a
range.
limit, means you can represent that solution with a simple equation which is bounded by certain limits.
Some value of the domain.
Yes. So since you can change the number and nodes and you can get a different thing, so FEM don't give you a closed form solution. It is always an approximate solution to the problem. And the C part, you all know that it is never exact. Means it can be exact, like the way we have.
Similar approximation.
See,
But
we
I
have
have one doubt here.
Yeah, tell me.
For example, I was seeing in the lecture when we were formatting any equation for the beam or say bar element,
Okay.
we were always defining the range for the x, like from 0 to L or
Yes,
0
yes,
to
yes.
1.
Yes.
So isn't it a closed form?
No. Closed form is related to the solution you are getting. Your solution should be bounded. Means every position it should give the exact solution. The 1 point value, which it doesn't give.
Okay.
So we are talking about the exact solution. So exact solution it can have, like we have understood H convergence and P convergence. So if we take too much of nodes, we can lead it to the exact solution, or we can go to upper higher order value solution. We can assume it and we can get the exact solution in that case as well. But generally we will say that FEM gives you a approximate solution. So let's solve this question.
Element.
Sure. I don't think anyone needs this the explanation for this. So it's generally the whenever you form this is the linear one. This is the element, and I'll show how the area and volume works. Let's say in 2D you are taking a triangle. So in triangle you do this. Let's say 1, 2, 3. So this will be A1, this will be A2, this will be A1, and this will be A3. So this is defined on the basis of A1, A2, and A3. Similarly, if you have a something like tetrahedral or thing, you will define that on basis of volumes V1, V2, V3. So all these V1, V2, V3, or here L1, L2, they are called as element of the FEM modeling. So correct option. So this the same. I think this is the same like the question. So choose the correct statement about FEM. It gives closed form solution. No. It is an analytical
Option
technique.
C.
No. This the solution exact the boundary. Yes, correct. The solution no. So this simple question. No problem. Okay, one dimensional element that is linear segments are used to model. Tell me.
Bars and trusses. Bars and trusses.
Bars and trusses. Structures. Someone said structures. No, structures won't be there because whole structure you can't model with one dimensional element. So also in a structure we can have the 3D degree of freedom. Means let's say a structure is there. So x, y, z whole will be there. So for 1D element we can do it by for bars and trusses only. Also we can't do beams by that because beams are like this. You have to get u1, u2 and one angle theta is also. So 3 degree of 4 freedoms at each node. What is the number of nodes? This is a simple question. Just have a look and tell me. Did you guys get?
Sir.
N plus 1.
Yes, n plus 1. How it is like this? Let's say we have 1, 2, 3. Let's say we have 6 nodes. So how many elements are there? 1, 2, 3, 4, 5. So whatever n will take, we know the number of nodes will be 1 extra. So directly we can say the solution is n plus 1. So how many nodes are present in 1D cubic element? This is the concept which I talk about in the last few questions. Just tell me. 1D cubic element.
Sir,
It's 3.
Okay.
no, sir, but thing is, it is one dimension, so it will be represented by one
Cubic, no?
Cubic, yes.
Quadratic is 2 or 3.
Mhm.
So cubic is 4.
Yeah. Did anyone have a problem in this, in thinking?
Yes, sir, I do. Can you please explain with some
Okay.
diagrams?
I'll do it again. This is 1 degree element. So for linear, you can connect this u1, u2, or I will not start with 0. You can connect it with linear element. So you require only 2 nodes for linear. For quadratic, you have to go with 3 points to make a unique solution. So if you have a square solution, u1, u2, u3 can go through this unique point. But let's see, we have cubic 1, and let's see I have 2 only. For this you can't follow a unique route with this. It can be a different thing. It's a simple way. You have to discretize this and say that 3-degree curves, you have to follow a 3 points to get a unique solution. Is 1, 2, 3, 4. If you have a lesser point than 4, you can't fit a unique polynomial in this path. So for that you require 4 nodes. Is the answer clear? Okay, I'll take it as that is clear.
Yes, sir.
Okay. So till now the 10 questions which I have discussed, It covers your assignment 1 problems. More or less, they will be solved by these concepts only. So since I have seen that, I think this fifth you have a summation of assignment number 2 also. So I have some questions which are now related with your assignment 2. So I've seen in the lectures that the faculty has covered the Rayleigh method and all, the weak form, strong form. Did you guys got the concept of everything? Is it clear, or you have
It's
some
not absolutely clear.
Okay, not absolutely clear.
Sir, no, sir. I didn't watch any of those lectures yet. Week 2, I haven't started.
Okay. You should watch it. Otherwise, you will be lagging behind, because you have the
Okay,
assignment
sir.
at 5 also, submitted at 5. It's already 1. Any difficulty
I think,
you?
sir,
Hmm.
it is better for all of us if you solve one simple problem using the strong form and the weak form, explaining the.
It will be covered in these questions. As last time I have covered the theoretical part, I didn't cover full theoretical here, because I thought theory is done there. But let's see. Let me solve these 10 questions. What I have, I think you will have a
Yes.
gist of things. If not, I'll try to get to the theory as well. Okay.
Okay.
So let me give you one theoretical before also, so that it will be helpful to you all to get it. Okay, let's discuss some theory. The faculty has started with the variational method. So I'll give you the summary of what he has taught. So every problem, let's say what you are solving is a growth of something. Means let's say you are solving a growth of a tree, just a random problem you are taking for your research and all. You don't know what it is, how you will form a weak form, strong form. You don't know how to solve a different, which differential equation it will follow. And we are saying to solve that growth of a material with FEM. What you will say, that I require a differential equation to solve from FEM. But where is the differential equation? For the simple problems like beam, bar, stresses, you have it. You know how this differential equation look like. So variational method is a method where we use the potential energy function to get to the differential equation of any system. So we start with the potential energy function. What potential energy function says? Strain energy minus work done. Everyone understood this equation? Potential energy of any system is equals to strain energy minus the work done of a material. Let's say now what I'll do, I'll solve it for a beam. Let's say if I have it, okay. Okay. Let's solve a axial loaded bar. Now for this potential energy function I have to find. Okay, let's solve the beam element. Simple beam element, let's solve. So we know strain energy for this function as 0 to L m square by 2 EI dx. minus, let's say, sub q naught is acting here, q naught w dx. Is it clear for everyone? This is strain energy. No, this is wait, this is pi. Wait. Sorry for the confusion. So from strength of material, we know that for a beam element in with moments, will have this much strain energy. And what this is q into w, or you can say u naught into u, which will be ux. So this is the load into displacement. So you will get a work done here. This is work done. This is strain energy. So for any material, you want to model a growth of something, you just have to write the potential energy function of it, and you solve it by variational principle, by like this. So what it says, f of x w dash. So do you know what functional is? Functional is functions of functions. Like a function pi is defined by a function which is itself a function of some u. I should use u instead of w. So it is a function of u, its derivative, and maybe triple derivative as well. So function is itself a function of function. So it's just a rolling thing. So if the function is a function of function also, then we call it as a functional. And to solve it by variational principle, we get the what you say as a Euler-Lagrange equation, which is del f by del w minus del by d by dx of del f by del w dash is equal to 0. So for any growth, you have to find the functional which it is dependent on, and just have to apply this equation, Euler-Lagrange equation, to get the differential equation. When you get the differential equation of a physical process, you can just apply the FEM to solve it. I know it's a little confusing here as well, but when we will start the question, we'll get to it, how things are being done. One more thing. Okay, let's start with the questions. Let's see what this question says. It said, let the differential equation is this. For 0 to 1, consider PQRF as known as the x function of x. Phi is a field variable, V is the weight function. And you have to find the weighted residual method, you have to solve it. So do you guys know about residual thing, weighted residual thing? Are these things clear with weight function, field function? Is it clear in the course?
Yes, I've seen the videos, but I've not yet solved the assignment all, so
Okay.
not so confident.
Okay. Just no. I should have prepared a theory as well last time. Okay, so what we can do a theory as well. Okay. So are you guys familiar with this equation? This is simple, the equation of an axial loaded bar. Okay, B is the force acting per unit length. So means it's nothing but just the AE d2 ds square is equal to function of load. So this is the differential equation which you will get when you solve a variational principle for an axial loaded bar. So now this, since this is your differential equation, we call it as strong form. So I'll define strong form as, strong form is a form of differential equation which deals with original governing equation. Of the physical form. So any mathematical differential equation you have got, if you find a exact solution by some of the methods what you have found by in the mathematics, you will get a exact solution. You will say that is a strong form. But in solving the FEM, we have to find out the weak form. How to find a weak form? We take a two functions are there. I'll make a weak form. So how weak form is shown? There are two functions. One is trial function, one is weighing function. Trial function is the u bar which you assume. Means let's say the solution is of cubic form, you don't know, but you assume u bar as a0 plus a1x. So whatever you assume the solution is u bar as trial function. So what weighing function is, it is applied with the what should say, it is another function which to tell you, it is applied to get the residual less. Means if this is the equation, ae d2u by dx square plus b equals to 0, you have to multiply a weighing function w. Since you are using this u is not correct, if this u is exact, what you will get, this full as 0. But since you are not using this u as 0, so this will not be equal to 0. So what we'll do, we'll multiply this something with w, so that whenever this is not 0, this will make you 0. I know this is very confusing, but I didn't prepare the theory part, so I'm unable to let you know. But let's cover with the questions. So consider the p, q, r and f as the unknown function, x and y as the field function, v is the weight function. So I think I have to solve it. Okay, so the differential equation which is given, p dq phi divided by dx cube minus q d2 phi by dx square plus r d phi by dx equals to minus phi is equal to f. Okay, so what residual is, whole this p dq phi by dx cube minus q d2 phi dx square plus r d phi by dx minus phi minus f is equal to, this is r. Why this is R? You are putting a solution which is not correct, so it will lead to a certain value which is not correct, which is not equal to 0. So you will get a residue as something which is you will get a value which you will call it at residue. So for weighted residual method, you have to multiply 0 1 v r tx is equal to 0. So when you solve this, you will get 0 to 1 v p d3 phi by dx q minus v q d2 phi by dx square plus v r d phi by dx minus v phi dx equals to 0 to 1 vf d. Just I have expanded things and your answer will be D. Okay, so let's see this question. So consider a bar of length 2L is subjected to an axial load P and an axial distributed load Q as shown in figure. The displacement area Young's modulus of bar is given. What is the expression of potential energy? The problem. So this is a, you have to find the potential energy of a given bar. So anyone who want to try? So I'll tell you the pi will be strain energy minus work done. So work done will be calculated on the basis of this external forces, and strain energy we know from strength of material that will be 0 to 2L to 0 to 2L 3A by 2 du. Like, wait, I'll tell you in more deep. This will be half stress into strain dV. Are you agreeing with this is okay, strain energy? I think you all know this. Is it fine?
Yes, sir.
So
Yes, sir.
now sigma is E into epsilon. E will be du by dx. So when you put in this, what you will get? Half E du by dx, and one more epsilon is there, so you will get du by dx dv. Now this dv you can write a dx, so it will be half E du by dx whole square into dx a also. Okay, so this is your strain energy for the bar. Now work done. Let's calculate the work done. Work done will be the contribution from this P and this Q. What work done is? Work done is force into displacement. So work done by Q will be 0 to 2L Q into U dx plus U at 2L into P. So I'll explain what this is. This is load into displacement for 0 to 2L. You see that load is acting at all L2L element. So force into displacement. How this U into P is coming? U at 2L into P. Force and displacement of this point. So don't confuse this 2L. This is the internal point, means U at 2L. So load into displacement, you get the work done in this case. So if you write total value of pi, what you will get? You will get Uh, someone is on mute. And someone. Can so that's Gaurav? Can you unmute? Okay, thank you. Okay, so what we get the pi as strain energy, which is half AE du by dx whole square dx minus of 0, this is also 0 to L, qu dx minus u of at 2L into P. So what are the options we have? These are same C options we are giving. So this is the solution. So you see, where you have to find the potential energy. The initial step of solving a variational problem is to get the potential energy function. So for potential energy function, you should know the strain energy and the work done. So in this simple problem, you must have understood how to get the potential function of a system. Now let's look into other question. Suppose the axial load P is removed from problem 2 so that the bar is subjected only to axial distributed load now. Okay. So how was the problem? Like this. And he's saying that external force is reduced. Only this is left. Okay. Answer the following question. First, you have to find the Euler-Lagrange equation. Okay. So this is Q. Okay. So Euler-Lagrange equation you have to find. So 3A. How we have found this? It should be 3 here. Okay, I did a little mistake in this question that E is given as 3E. So wherever it will be 3 here, 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 it will be, so that's why question 3A by 2 is coming. Okay. So the way we have solved the potential energy function, we have to find it here as well. Either way, we can solve it full or we can use the last solution. So you know that this part is the strain energy which won't change. Either we change the boundary condition or not. So strain energy in the material will remain same. For this question, next question, we don't have P. So what pi is remaining is this. So we can directly write potential energy function as 3A by 2 du by dx whole square dx minus q u dx. I hope you can get this solution from starting as we did in the previous step. I'm using the result of the last one. So this can be written as 0 to 2L 3AE by 2 du by dx whole square minus qu dx. So if you have to get the functional of any of the potential energy function, this is the, let's say, L f of x u dash. This is a general equation of this. If you compare this equation with this, what you can get, that you can get the functional of this problem, which is functional as x y y dash. If I have written x y y dash, I should write u. Wait. X u and u dash. See, it is dependent on x, it is dependent on u, and it is dependent on du by dx. So three variables are there. which we have written like this. So what functional we will get? We'll get 3a e by 2 u dash whole square minus qu. The same thing which is written here. We have compared it and got the functional of this system. Now what Euler-Lagrange equation, what we have to calculate in this equation solution is, we have to get the Euler-Lagrange equation, which we get by this del f by del u minus d by dx del f by del u dash equals to 0. So now we know f, which is this, and we can solve the solution. So when you will do del f by del u, what you will get? You will get minus q. Is it okay? Then
Yes.
d by dx of del f by del u dash. What you will get in this? Tell me.
3ae into du dx.
Okay, 3ae into u dash directly you can write.
Yeah.
Okay, so this should be equal. So your Euler-Lagrange equation is d 3ae u dash equal to 0. So this is the solution, which is 3ae du dx. See, I think this is the solution, plus q equals to 0. So you can directly make it positive, and the solution is B. Everyone clear with this? Should I repeat? I'll wait for 2 more minutes if anyone want to get to this problem again. Clear? Okay, perfect. So I'll repeat that. We have started a potential energy function. We can form a differential equation through it, or we can get a Euler-Lagrange equation to get a differential equation of it. Now let's. What is the number of required boundary condition to solve the problem? So now what our problem is? Our problem, what we get is this q plus d by dx of 3ae du by dx equals to 0. Now I think you should be in position to answer this question. What are the number of required boundary condition to solve this problem? Give it a try.
Should be 2.
Okay.
Option B.
Why 2?
Because the degree is 2.
Perfect. So we, in differential equation, we know the total number of boundary conditions are same as the degree of differential equation. So here q plus 3ae d2u by dx square is equal to 2. This is our governing differential equation. So we can say the degree is 2. So we require 2 boundary conditions. So this is the same part of the question. What is the expression for strong form of the problem? So what I had told you, that what is the strong form is, it's the differential equation along with the boundary condition which our governing system holds. So what differential equation I have got, I'll write again, which is q plus 3ae d2u by dx square equals to 0. Is it fine? Yes, it is correct. So since our system is 0 to 2L, we can write this as this. So this is our whole of the differential equation. Now we require boundary conditions also to write full strong form. So what was question was? Question was like this. Now you say x is equal to 0 is this, x is equal to 2l is this. So x is equal to 0. We know the condition is y is equal to 0 because it is a fixed support. Now at this point it is a free end, so we know that 3ae du by dx will be equals to 0. This is the force condition which is 0 at free end. This is the displacement boundary condition. So if you see which is the answer, no, this is not the answer, this is not the answer. I think this is the answer, 3ae d2u plus q is equal to 0. Yes, this is the condition. So your answer will be C. Okay, now what you have to get, you have what is the expression from weak form for the bar problem if V is the weight function. Okay, now you have to find the weak form of the strong form which is given in the previous we have found in the previous solution. So what is the strong form we got? So it is given the V is the weight function. So to get the weak function, what we'll do, we'll multiply the weight function with the differential equation. Plus q dx equals to 0. So in the inside term which is written is the differential equation which is in the strong form, and this full is being done to get a weak form equation. Okay, now we have to solve this to get the weak form. What we can do, we can write this as this 0 to 2l 3ae v d2u by dx square dx plus 0 to 2l q v dx equals to 0. Okay, now you have to use integration by parts in this, and if you solve integration by parts in both, what you will get is 3v ae du by dx, which will be x is equal to 0, plus 0 to 2l du by dx 3ae, and it will be du by dx again, and equals to 0 to 2l. Wait, I'll write next page. So it will be 3v ae du by dx at x is equal to 0 plus 0 to 2l dv by dx 3ae du by dx is equal to 0 to 2l vq dx. So what we have done, we have just solved this integration by parts using Eilert rule in 1 and 2 and get this solution. So this is your general weak form solution, weak form equation of a strong form, which was this. So which is the answer? The D is the answer.
So what is the value of the first part for x equals to 2l? Because if you do integration by parts,
Okay, so no, it will come when you put 12 is na, you have to satisfy this equation, it will go 0.
okay.
है ना?
Yes, got it.
Why we are not putting it to 0? Because this is force, and we at x is equal to 0, we know u is 0, but we don't know what f is. So we have to put it the boundary term side like that. If other term will be 3v ae du by dx at x is equal to l. This term you are talking about? This is the term you are talking about, na?
Yes, 2l at 2l.
12, sorry.
At 2l it will be 0.
So it will be 0 when we use this condition. So it will be a crystal shell.
It was zero or it was
It was zero. It was zero.
given.
The force at this point is zero, na?
Oh, the force is being removed. Yes, yes, yes.
So force is not there, na? So you know that
Yes,
it
yes.
is zero.
If force was applied in the original problem, it would be
That force. It will be that force.
Yes, yes, yes. Got it.
It would, so you have to write if Fp will be there, you will write 3V and into P, because this part will be P. I think yes, no? Means
Yes, yes. Got it.
understood. You must have got it. Okay, so this is the next question. A little big question. Read it. So it says a simply supported beam having a length 2L, Young's modulus E, moment of inertia 3I is subjected to uniformly distributed load Q per unit length. Okay, let's draw and then see how UDL is acting. Q, vertical displacement and weight function WV respectively. Choose the correct option for following statement. Okay, so this requires a solving. Let's do it together. So one potential energy we have solved for axial loaded bar. Now we have a bending problem of a beam. So let's start finding the potential energy function for a simply supported beam with moments and all. So with Q as a distributed load. So pi, as we know, is strain energy minus work done. So strain energy we can write as 0 to 2L m square 2E. Now here I is given as 3I, so we'll write it here as 3I dx minus 0 to 2L Q naught W dx. What this is the work done. Is this step clear to everyone? Because this is starting. If you are stuck here, you won't understand further. Is it fine for everyone?
Yes, it's okay.
I hope. Okay. So, okay. So, what we'll do, we know the basic M equation, which is minus EI d2W by dx square. This is the basic beam equation we know. But here we know that I is 3I, so we can write it as minus 3EI dq by W by dx square. Now when we can put this M into this equation, and what we'll get 0 to 2L 9EI by 6 d2W by dx square whole square dx minus 0 to 2L Q naught W dx. Just I am putting M into this and solving the showing you the final version. When you solve it, you will get 0 to 2L 3EI by 2 d2W by dx square whole square dx minus 0 to 2L. Just nothing I have done, just cut the 3 and 3. So the final pi will be 0 to 2L 3EI by 2 d2W by dx square whole square minus Q naught W dx is equal to 0. So like in the previous question I told you that this part is the functional. So here what functional is? Functional is a function of x, w and w dash. We can observe here there is no dw by dx. So it is not a function of dw by dx, but it is a function of x, w and w double dash. Okay, so now we can use a Euler-Lagrange theorem, Euler-Lagrange equation I should say. So Euler-Lagrange equation we'll write it as, we know it is del f by del w minus d by dx of df by dw dash plus d2 by dx square df del f by del w double dash equal to 0. Okay, so this is the Euler-Lagrange equation. Now if you see that our functional is not a function of w dash, this is simply 0. Now df by dw, it will be what it will be. We will do a dw by df and you will get this minus q naught. So this will be minus q naught here plus 0 plus here it is df by d w dash double dash. So this is the condition you will solve. You will get 3ei and dw double dash. So when you will write this, you will get 3ei the outer d2x by dx square will be there. Inside it will be 3ei d2 dx square. Okay, I hope this is clear. Then this is q naught 3ei d4 this. Okay, so can you guys tell me what this is, what this differential equation suggests you? It has a proper name in the civil engineering, means structures or strength of material. Do you guys have any time? Euler-Bernoulli, perfect. This is a Euler-Bernoulli equation. Okay. So now what is we see that the differential equation is based on power 4. So the first equation, the first option is wrong. It says Euler-Lagrange equation of second order. No, it's a fourth order. Other thing is it's saying is the weak form of the beam is this. Now okay, let's solve the weak form as well. For weak form, what we have to do? What is the solution it is given? 3ei. Okay, for weak form you have to okay, so let's solve the weak form equation. The equation which we have got is 3ei. Okay. Okay, so we'll solve it as 0 to 2l v. I think they have used v only, no? Okay, they have used a v only, so we can use v minus q plus 3ei d4 w by d x power 4 equals dx equals to 0. Okay, so this is the way to solve the get the weak form equation of the Euler-Bernoulli equation. Now we'll see how to solve it. Okay, so this is the equation. Now you see there is 4-degree equation. So we'll apply the integration by parts here also. So what we'll get is v v 3ei d cube v by dx cube 0 to L minus 0 to L 0 to 2L 3ei d cube v by dx cube dv by dx into dx. So you see this, there is an integration again here, and we need to solve this again by integration by part. So when you will solve this, you will get w 3ei d cube v by, oh sorry, I think I missed something. This should be one is w, wait. This is w, because this is w, sorry, the confusion. This is w, so this is w, this is w, okay. So now I have taken w here, so this will be so wait, I'll do what I'll do, sorry for the confusion. Let's take this equation as ei d4v by dx power 4 minus q is equal to 0. Let's take w as weight function and v is the trial variable. So what we'll write, we'll write theory will be there. So w 3ei d4v by dx power 4 minus q dx equals to 0 from 0 to 2l. Then we'll use the integration by part. We'll get w 3ei d cube v by dx cube 0 to 2l minus 0 to 2l ei d cube v by dx cube dw by dx into dx. So we'll do a integration by part again in this, and we'll get w ei d3v by dx cube 0 to l, then minus dw by dx ei d2v by dx square 0 to l plus 0 to 2l ei d2v by dx square d2 cube by dx square dx. Now what you will do, you will in the you will do solve the full equation, and in the end you will get 0 to 2l 3ei d2 v by dx square d2w by dx square dx plus ei 3ei w d cube v by dx cube, which is 0 to l, minus ei dw by dx d2v by dx square 0 to 2l minus 0 to 2l w cube dx is equal to 0. So this is your weak form equation, and what solution we will see, the problem which will be, it is gone, so too big. So the solution will be
The third term should be 0, no? Because it's moment. Moment at the ends are 0.
it will be 0. It will be 0, but this is the generalized term I have written. I have not put the boundary boundary conditions here. It's the general term. So when you put it as 0,
Okay.
the solution what you will get will be D part, where 2 is true and the number of required boundary condition is 2. 3 is false. Okay. Or one. So it, since it's the 4 degree equation, you require a 4 boundary condition, not 2. So this is wrong, but this is correct. You solve it by hand. You will get the solution. If not, I'll go to 3 again in the next class. So let's see this question again. The next question. Differential equation is given, and you have to find the bilinear and the linear function when v is the weight function. I think this is the two questions are okay. So okay, I'll solve this. So this is 0 to 1. The domain is given as 0 to 1. Since we have to find the weighted function, so we'll multiply this with v d2u by dx square minus u cube minus 3x power 4 dx equals to 0. Okay, now you must have got this. So if we do an integration by part, we'll get v du by dx at x is equal to 1. Other will be 0 because this is 0. Oh no, this is not 0. X is equal to 0 at 0. It will get okay, let's see. This is going to be 0 to 1, then dv by dx with du by dx plus v of u cube whole dx minus 0 to 1 3v x power 4 dx is equal to 0. Okay, now we'll apply the boundary condition and we'll get it as 0 to 1 dv by dx du by dx plus vu cube vu cube dx equals to v at 2 minus 0 to 1 3v x power 4. We have put the boundary condition. So you can see that this is the bilinear term and this is the linear term. So in the question you see the bilinear term matches this and linear term matches this. Okay, now this is also a good question. Let's solve this now. So here what it is, you have the governing differential equation which is subjected to the two of the boundary conditions. U is the one of the approximate parameter where u is given, phi naught is given, and you have to use a Rayleigh-Ritz method to obtain a function, the parameter like this. So we can write here as 0 to 1 d v by dx okay, dv by dx 1 minus x square du by dx into dx is equal to 0. Condition is this, not this. So what we're doing, subjected to consider Rayleigh method. If subject p is subject phi, using expression is obtained as this. What is the value of b11? Okay, governing differential equation is given. T2u by dx square is equal to 0. B is equal to phi 1 CT. Okay, so this will be the weak form of the equation you will get from this governing equation. If you solve by you will use a residual method to solve this and you will get a get the weak form as this. So what other things are given as v as phi 1, which is x 1 minus x, and u, which is u bar, is given as c1 phi 1 plus phi naught, and it will come up to c1 x 1 minus x plus x. So these are all the given parameters I have written. Now when you go to solve this is 0 to 1, 1 minus 2x, 1 minus x square, then c1 1 minus 2x dx is equal to 0. Where I have got this is du bar by dx, which you will do like this. So you will get c1 1 minus 2x plus x. So when you put, you will get this. Now you just have to solve this and get the solution. So when you will solve this, you will get okay, c1 will also be there. When you will solve it, you will get c1 1 minus 2x whole square 1 minus x square dx from 0 to 1. When you solve, you will get c1 out, integration of 1 plus 4x square minus 4x 1 minus x square. When you will solve this, there's some simple integration. So you will get c1 minus 4x power 5 upon 5 plus x power 4 plus x cube minus 2x square plus x from 0 to 1, and you will get a c1 into 1 by 5. So in the question it is saying f1 equals to b11 c1. So b11 will be your this, which is 1.1 by 5. So answer will be A. So this is all I have for today. I know a little confusing with the since you have not seen the lectures properly, but it's important for you all to listen the lectures first before coming here, so that you can get the gist how to solve the questions. Another thing, anything you want to change or want me to cover, you can still tell me. Otherwise, this is all I have for today. All these questions will help you to solve both the assignments, so you can go to them, and the last date is 5th. I hope you will submit the assignment till then. Anything problem you have with the today's lectures, you can ask now.
I have one question regarding the in the last part of the lecture, which
Okay.
I was seeing. The faculty member was proving the bilinear and linear and means the cycle of strong to weak form.
Okay.
Means when we can go to from the weak form to the strong form as well.
Oh, he was going from weak form to strong form as well.
Means he was proving it that if the means the bilinear function is symmetric,
Okay.
then we can proceed from the weak
Weak
form
form
to
to
the
strong form as well. Yeah.
form as well.
Uh,
So that statement I got, but the manner in which he was proving, it was a little bit confusing for me. So I didn't get that part.
so from the
So
lecture part or my
yes,
lecture?
from the lecture part.
Okay, I
No,
have
no,
to.
not from the what we discussed.
Okay, I'll keep a
That was
note
a
of it.
little bit theoretical part. Means
Uh,
I don't think it will uh, without that also I can solve the assignment, but it's a
that
theoretical
is
part.
just a more knowledge of that how you are going from weak form to strong form again.
Yes, yes.
So I haven't seen the lecture, so I have to see. But I'll try
So
to
it's in the
answer.
last part of the lecture, I think.
Okay, I'll have a
Means
look on it.
the really weak method one, I think.
Okay, I
It was
understood
the
what
one.
is your problem,
Yes.
but I'll look into it the lectures and let you know in the next.
Yeah, in the next week we can
Sure,
discuss.
sure, sure. Anything, anyone? I'll post. I hope if you don't get these videos, type in the YouTube FEMTA sessions. You will get it. Yeah, both. I think I've seen the submission date as 5th. Uh, so keep a check that you all submit the assignment till it's 5th or 7th. You have to see. I don't remember the exact date.
It is
It's
fifth,
fifth
sir.
for both
Fifth.
the
Fifth.
assignments.
For 5th.
Both
So
assignments.
try to submit that by then. After that, we can discuss the questions of that assignment in the next lecture as well. Anything
Sir,
else you
here what I want to,
want? Tell me.
sir, I am Nandalal. Here what I want to request you now, sir. Whatever the questions you have solved, whether we will get this video.
Video you type in the YouTube channel FEMTA sessions. I'll show you again.
FEM.
See, I'll write here FEMTA NPTEL TA session. You will see this Nikhil Gupta, and the session 1 is already uploaded. To by today, I'll submit the today's lecture as well. So no need to worry. You will get this. I'll since you are saying that you don't get this PDF link as well. So I'll upload the link into the Google Forum session so that you can have the access through it. Is it fine?
Yeah, okay. Thank you, sir.
So FEMTA session, you search FEM NPTEL TA session, you will get there. So anything else you want to cover? Means is it fine if I cover the questions related to the sessions and the assignments, or theory part you want? Because theory
Okay,
is
sir. Yeah. What I am telling, I have not go through the theory, lecture total. That is why I'm not able to. If some doubts will be there in the lecture, we will discuss with you also, sir.
sure. Because I am not watching the lectures, so when you will tell me, I'll discuss in the next class.
Okay, sir. Okay, fine.
Or you can post your doubts in the Google session that group as well. I hope you all have that access to that group.
Yes, yes.
You must have been getting the mails regarding that. I'll wait for a few more minutes. If you have some doubt, you can ask.
Okay, thank you, sir.
Okay, thank you.
Okay, thank you, sir. Bye.
Thank you. Bye. Thank you for attending the lecture.